Hello, algebra students. Welcome to lesson 7.1, the first lesson of our geometry unit, and this deals with angles formed by parallel lines and transversals. It covers pages 166 to 192. That's not right, 186 to 192. I thought, oh my goodness, that is forever, but it's 186. So sorry, didn't mean to give you a heart attack there. It does cover a lot of pages because what this lesson does, it takes what we have learned in all of our Singapore math arithmetic classes, plus the review and continued work last year in pre-algebra, and it condenses this all as a review lesson in lesson 7.1. So get ready, there's a lot of notes today. The first four pages are simply reviewing all the properties of angles that we know. So let's begin. So to review, general angle properties are as follows. First one, the sum of adjacent angles on a straight line is 180 degrees, and you abbreviate it like this. The reason you abbreviate this is the proof of what you're doing when you're solving a geometry problem. You always got to offer a proof statement. This is how you can abbreviate that first property. The next property is the sum of all angles at a point is 360 degrees. So angles at a point. And this one, of course, was adjacent angles on a straight line. And our third property is when two lines intersect, the vertically opposite angles are equal. And we would abbreviate this property, vertically opposite angles. So they give some illustrations of this, and you should jot this down so you can remember it and you can see how to use the proof sentences. So it says in the figure, ABC is a straight line. Therefore, ABC is the straight line. Therefore, angle A plus angle B plus angle C equals 180 degrees because of the first property, adjacent angles on a straight line, all total 180. The next figure looks like this. In this figure, we have angle P plus angle Q plus angle R plus angle S equals 360 degrees because the angles they all come to a point in the middle. So angles at a point total 360. Then to illustrate the last property that we just now reviewed is, let's see and get this in here. In this figure, AOB and COD are straight lines. Therefore, angle A equals angle B, and boy, making mistakes left and right, and angle X equals angle Y. And we can say those pairs of angles are equal to one another because of the property of vertically opposite angles. Continuing, we need to know parallel lines. Parallel lines are lines that extend in the same direction and remain the same distance apart, never intersecting. And we indicate sets of parallel lines by the number of little arrows. So if we had another set of parallel lines, they would get two of the little arrows to show that they are parallel. A transversal is a line that intersects two other lines. Now those two other lines do not have to be parallel, they're just two other lines. A line that intersects two other lines, and this forms 8 angles, which are named in pairs of corresponding angles. So we have a situation here. We have line AB and CD. It's intersected with TS, therefore TS is the transversal. Now here we go. Angle P and angle A are corresponding angles. Angle B and angle Q are corresponding angles. So these two go together, these two go together. Angle C and angle R are corresponding angles, and angle D and angle S are also corresponding angles. So study that out so you understand what corresponding angles are. Like always, pause, take a minute, reflect, rewind, whatever you need to do, ask questions. Also, we have another set of lines with a transversal. In this case, we have angle A and angle R, and angle B and angle S are alternate interior angles. So they are within the interior of the figure, and they are just on one on each side, one on the bottom, one on the top, one on the bottom, one on the top. Then we also, within the interior angles, have them both on a side. So A and S are interior angles, and B and R are interior angles, and those would be on the same side of the transversal. So continuing on, there are some more properties to understand. When two parallel lines are cut by a transversal, number one, their corresponding angles are equal. Number two, their alternate angles are equal. And number three, their interior angles on the same side of the transversal, so like this, are supplementary. So now we have to have a couple more terminologies remembered by us. So the vocabulary, remember, complementary angles total the 90 degrees. So if you add them together, they're 90 degrees, and supplementary angles total 180 degrees. Okay, so now we've gone through all of the review. That's a lot to remember. Now we're going to go on to the triads. Okay, the triads. Now with the triads, you really have to keep your wits about you so you know what you are looking at. So let's begin. Triad number one, page 190. In the figure that you see in 190, AB is parallel to CD. And you see those two little arrows that indicate that. And then they want us to find the measures of angles P, Q, and R. So looking at that figure, we would know that angle P equals 115 degrees because of the alternate angles, the alternate interior angles measurement. So let's just take a look at that. So here's 115, here's the alternate interior angle. They are equal. Okay, continuing, angle R, therefore, is also equal to 115 degrees because they are corresponding angles, because the lines are parallel. That's all this means. They're corresponding angles. Then angle Q would be, angle P and Q are forming a straight line. So they are interior angles, opposite interior angles actually, and they total 180. So angle Q is going to be 115 plus Q would total 180. So you just would subtract that. Angle Q is 65 degrees. Okay, you might have to go over this one more time a little bit slowly to see everything there is to see. There's a lot to be seeing and understanding here. Okay, continuing on though, once you understand that, we'll go to triad 2. Trying to figure out where to go with the book. I think I'll just leave it up here. Okay, triad 2 looks very complicated, but once you sort it out, it truly isn't. Just notice what goes with what, which parallel lines go together, and what are straight lines, and so on and so forth. It says in the figure, AB is parallel to DE. Find a minute, look at that. Also, BC is parallel to EF. Now here are some angles. BHC, oh, those are straight lines. BHC and DHE are straight lines. So you know everything along those two lines are going to be 180. Find the values of x and y. So this is how you do it. Angle x is going to equal angle EHB because of the alternate angles. Therefore, it's going to equal ABC because of alternate angles. And because of that, angle x is going to be 72 degrees. So let me just show you that. Not sure where to go. Here we go. I think I'm just going to move this up a little bit. There we go. And then I can maybe get this. And my book does not fit very well under here. Okay, so angle x is equal to angle EHB because of the alternate interior angle thing. Okay, here and here, they're opposite and interior, so they're the same. And then angle ABC, it's also equal to that because angle H is here. So x to H, these three are all equal. Therefore, angle x is going to be 72 degrees. So if you see this to this to this, since this little angle is 72 degrees and is equal to angle here at H, then angle E, which is equal to H, is also they're all going to be 72 degrees. Okay, now angle Y then, if this is 72 degrees, notice it sits on a straight line, and all the angles will total 180. Therefore, I know this is 72. Therefore, 72 plus 23 degrees plus Y is going to be 180. And I think I have that written out. I do. Add those together. It's 95 plus Y is 180. Then you just simply subtract to get Y, 85 degrees. So angle Y is 85 degrees. Okay. Then we have try it 3, which goes to the top of the next page. This is interesting because the shape that you see at the top is incomplete. And I just gave you a little heads up here. Sometimes it's necessary to construct lines to help find the solution. So we needed to make this line so we could split this big angle X into two parts. That will help us because the way it's just simply drawn in the book, there's a part missing and you can't figure things out without adding that dotted line. So first of all, you need to construct a parallel line that is parallel. So CF is parallel with ED and BA. Now we can go about finding out what they want us to know because they want us to find the measure of this whole big angle. So to do that, angle ECF is going to be 20 degrees because of the alternate interior angle. So this is 20 and this is 20. So when we drew this parallel line, we could use that property to say, oh, this part's going to be 20 because that part is 20. Angle BCF is going to equal 180 minus 55. Now, how do I do that? Well, interior angles, which this and this are actually this part, x2 and 55 are alternate interior angles, and that property says they are worth together 180 degrees. So 180 minus the 55 gives me 125 degrees right there. So to find out the total measurement of the entire angle X, I simply add 20 degrees plus 125 degrees, and I have 145 degrees. Okay. The key to this lesson is to go over all those notes that we took at the beginning. Really study the pictures that go along with the notes so you understand the vocabulary and what is what. in order to do the upcoming exercise. Then go over these 3 triads. So you see, particularly this one, because if something just isn't working out, you're going to know, oh, I got to construct a line somewhere. What can help me figure this out? And that parallel line is what was key to figuring out triad number 3. With all that, I'm going to let you review, consider, and as always, ask questions if you do not understand, and I will be giving you your assignment in class. And as always, do good math. Thank you.